So before we complete 6.4, which is a section on work, I think I'm going to go ahead and complete 6.5 before, right? When we're looking at the average value of function. Now, when we talk about the average value of function, you know, average stands for mean. We're looking at the mean value of the function. Let me make sure that this is recorded. Okay, good. Now, if f, which is a function, is integratable, right? Sorry, not integratable, integrable. Sorry, meaning you can integrate it over the boundaries from A to B, then the average is going to be the sum of the intervals over the number of intervals. That's where you get the average. In a more mathematical term, then all we're going to be doing is to get the number of interval is 1 upon b minus a. B is the upper boundary, a is the lower boundary. And I integrate over that boundary of whatever the function is, right? So that's what we do when we are finding the average value of the function. Let's do an example so you can see exactly what we're talking about. All right, so in this particular case here we want to find the average value of the function y equals sine x on, this is a equals 0, b equal to pi. So all we're gonna do is take 1 over pi minus 0. Then we're gonna integrate from 0 to pi of sine x dx. And evaluate this and you get your result. So it's just going to be 1 upon pi. Then you're going to integrate from 0 to pi of sine x dx, which is just 1 upon pi. Now the integral of sine x is, what's the integral of sine x? That is minus cos x. And then we're going to go from 0 to pi. And when you work that out, you should get 2 upon pi. Very, very easy. Now the next one, you're asked to find the average value of the function f of x equal x cubed on the interval from 2 to 5. So it's just going to be 1 upon 5 minus 2, the integral from 2 to 5. Then we're going to take the function x cubed dx, right, which is 1 upon 3. Integrating x cubed, that's just going to be x to the 4th upon 4. And then you're going to go from 2 to 5, plug those in, and you should get for your results about 50.75 when you evaluate that. All right, that's what you should get. All right, next result, next example, I should say. Now here we're told that the average value of the function over this interval is 10, and they want us to evaluate the integral from a to b of f of x. Now just plug in everything that you know. So 1 upon b minus a times the integral from a to b of f of x dx is equal to 10. And then just solve for the integral. So in doing that, we can multiply both sides by b minus a to get it to cancel. So we would just have the integral from a to b of f of x dx is equal to 10 times b minus a. And that's how you would get your result. So set up the equation and then just go ahead and solve it. Next example, find the average value of the function 1 upon x on the interval from 1 to 3. Let's start with part A. So it's going to be 1 upon 3 minus 1 is 2. So that's going to be 1 upon 1/2. The integral from 1 to 3. Then we have 1 upon x dx, right? So this is just going to equal to 1/2. The integral of 1 upon x is ln x. Remember, if you differentiate ln x, you get 1 upon x. And then you're going to go from 1 to 3. And the answer that you will get is 1/2 ln3 once you work that out. That's for A. Now for B, find C such that the average value equal to f of C. So we want to find C such that the average value is equal to f of C. All right. Now let's see what f of C is equal to and then equate them and see what we get. F of C is plug C into the function. That would just be 1/c. Remember that f of x is 1/x. So f of C is 1/c. So it means that 1/c, which is the average value, must be equal to this result that you got. So let's set up the equation and solve. So it's going to equal to ln3/2. And then go ahead and solve for C. You could cross multiply. So this would imply that C times ln3 is equal to 2, which means that C is equal to 2/ln3. All right, that's what you would get. Then we have the last question here. C, sketch the graph of F and a rectangle whose area is the same as the area under the graph, right? So we want to sketch the graph of F, and then we want to also sketch a rectangle whose area is the same as the area under the graph. Now, I'm going to do it over here so we can still refer to this information. So here we have our graph. The graph of y equal to 1/x has this shape, right? Something like that. And remember the boundaries. Where are we going from? We're going from, let's say, 1 to 3, right? So we want to construct a rectangle, but we need to know the dimension of this rectangle. That will basically have the same area as the area under the curve, right? So what we do know, we already found it, we know a function value. We're told that f of c all right, I think I'm going to draw this a little bigger so we can see it better. And of course, if we draw it to scale, we get a better picture as to what is happening. But we won't be doing that now. Alrighty. All right, so we're going from 1 to 3. I still think I can do a better job drawing this diagram. I wish I had a grid to draw it on so we could see it. So let's get my rectangle. So this is 3 here. Let's say that this is 1. Now, right here where they intersect, as we can see, so that is 1. Let's say this is about 2. We already computed the value for C. So we would know what C is. Let's say it's at that point. What's C again? C is 2 upon ln 3. And the average function value is ln 3 upon 2. All right. So what would force these to have the same area? So if you look at the rectangle that we sketched, notice that the width of the rectangle would basically just be 3 minus 1, which is equal to 2. So it would have a width of 2. And then the height of the rectangle would just basically be what would the height be in that case? That would just be ln 3 upon 2. All right. So that's what it would look like. So we'd have a rectangle with where the width is 2 and the height is ln 3 upon 2. Now, another way you could think of this is find the area under this curve here and just force the rectangle to be equal to it. So this is another way that you could do it. How do we find the area under a curve? We would take the integral from 1 to 3, regular area I'm talking about now, of 1 upon x dx, right? And so that would just be ln x from 1 to 3, and plug those in. So that's just going to be ln 3 minus ln 1. ln 1 is 0, so that's just ln 3. So the area under the curve between 1 and 3 would just be ln 3. That's the area. Now let's test to see if our rectangle is the same. If you multiply length times width, remember that area is equal to length times width, then you will realize that the 2's would cancel and you would just be left with ln 3. Right? So you would want a rectangle that where the area is ln 3. Right? Because you want it to be the same as the area under the curve. Right? So that's another way you could sketch it. Sketch a rectangle where the area is ln 3. So you could have one where the width is ln 3 and the height is just 1. That would force it to give you that area of ln 3. All right, so that's what we have for that problem. And then our final example is this one right here. So here we're asked to find the average value of the function. So how can we solve this if we're given the problem in this format? What we can do is to split these, right? We could split these into trapezoids. Right, let's see what we have here. Could split them up, because pretty much when you integrate, you're basically finding the area of each and then you're adding them together. That's what you're doing when you're integrating. We didn't even have to split it into so many. We could even, let's make life a little easier. This is a right angle triangle here. And we would be able to find, no, even from here, let's not give ourselves any work. We can find this area easily, half base times height. So we could call this A1. So let's call this A1. Let's call this A2. Could find the area of this figure and then call this A3 and then add them up. All right, so figure A1 is a triangle. So that's just going to be half base times height. So the base is 1 and the height would be 3. Plus figure 2 is a trapezoid. So the area is going to be half. You're going to do A plus B times height, where this is A. So A and B are the two parallel sides. So we call this like this is A and this is B, right? So it would be half A plus B, and then times it by the height, which is 1, right? So what is our A and our B? I will come back to that. And then figure 3 now would just be a triangle half base times height. Let's fill in our values. So this is just going to be half times 3 plus half. What is the A? A in this case is 3, B is 4. Notice this 3, 4. So that's going to be 3 plus 4 plus half. What's the base here? From 2 to 6, that's going to be 4. And the height is also from 0 to 4, which is 4. Then you would combine all of that to get the average value. And that's just going to be 1 upon, remember your formula, B minus A, so 6 minus 0 is 6. And then you would times it by the integral, but the integral is basically the sum of the areas. So you would just times it by whatever you get when you work this out. And that would be the same as the integral from 0 to 6, the area under the curve. That's what the integral is doing for you. So it would be 1 upon 6 times 13. And that's how you will get your result. All right, so that's what you would do. Now, number 17 on your homework, this is just a hint. So you can let 9 a.m. be t equals 0 and 9 p.m. be t equals 12. That can help you when you're doing number 17. That's a hint for that problem, right? And then these are your homework problems. All right, so I hope that you guys were able to follow. And if you have any questions, just let me know.